short sides. I put those on the bottom, and then your if you did it like that, you start at the top and went down the hypotenuse, then this is the order you get. Okay? Next page. Cross section of a group of seats at a stadium shows a drainage pipe BD that leads from the seats to the inside of the stadium. What's the length of the drainage pipe? So in this respect, it's easier if you drew the three triangles out so you can set up proportions. If you set up the proportions, then you can get what x is. So if I look at these two equations, or these two triangles, how would I set up the proportion to solve for x? Here.
X over 20, right?
Mm-hmm.
Equals 30 over 10 to the square root of 13.
Yeah, and then you just do cross multiplication and get done. Everybody got that?
Yeah.
And that's really what we're doing here. They drop the altitude down, so that makes all of them similar. Then we can do proportions, and that's what I didn't fill this part out because everybody knows how to do this. The whole key point behind this is that it's easier to set it up if you have them drawn separately, right? All right. Enough of that. Let's go to the next thing, and then we'll figure this stuff out. Let's talk about geometric mean. So there's two theorems, one with the altitude, and then we're talking about the leg theorem at the bottom. The altitude theorem, you drop the altitude down, and you can set up the proportion for the things that you need, and it becomes the geometric mean. They didn't draw the three triangles, but if they did, you could see where the geometric mean comes into play. So BD, the short leg here, is to CD, the long leg. The short leg is the long leg of this little triangle, as CD, the short leg, is to the long leg of this other triangle. And notice that these two are exactly the same. This is what you get for your geometric mean. BD times AD. Look at what you have. The altitude that cuts this side is the same as if you just multiply these two together and take the square root. That's the geometric mean. You could you could just separate them and do the proportion if you wanted. But the point behind this problem is, if you take the altitude, all you have to do is multiply those two distances together and take the square root, and that is the altitude's length. Got it? Or you just separate and do the proportion. But the point is, you need to know what the theorem is. The one down here, if we take a look, I'll just move it up a little bit. The leg theorem, we have two different things here. So AB, the hypotenuse, is to the short leg as CB. The hypotenuse of the little triangle is to the short leg. And the same type of thing here. Well, I guess what we're going to look at is the CB. This is just the leg. If I want to know what the leg is, the CB part, all I'm doing is taking AB, the hypotenuse, times DB, the long leg. It's just a different way to look at it. Okay, but if you can pick up on what it is you're trying to find, you can use geometric mean to figure this out. This one down here, AB, the hypotenuse, is to AC, the long leg. So the long leg is to the hypotenuse, AD of that one, or the, excuse me, AC. What is AC is to AD? Yeah. Okay, so you ought to be able to take those and understand how to use the geometric mean to solve it, or just separate them, which takes some time, and do proportions. I don't really care, but you do need to know how to use the geometric mean, and today's focus really is about this. Understanding how to set them up, either the altitude or the leg, whichever one you're doing. But it's real simple just to multiply the two numbers together and take the square root if you recognize that's what you have. Right? Okay. Obviously the altitude one is a lot easier. Drop this altitude down. This altitude is those two multiplied together in the square root. This one is the one that there's two different ways to do it, depending if you're looking for the short leg or if you're looking for the long leg. Alright. Anyway, that's what that is. Let's look at a couple, or this last example that's up here. If I wanted to know how high this is, what's funny to me is they measure this and they know how high this is. Certainly they can, whatever they have they can use to measure. Really they should have used a different example where they couldn't physically take a tape measure and measure the height of this beam that's up here. They totally could have measured that. But anyway, you can use the triangles to figure this stuff out. And they set it up like a geometric mean. I went ahead and drew the three triangles out separately here, just to show it, okay? You know that 6.9 is the geometric mean of x and phi. The altitude is the geometric mean of these two lengths. 5 times x, and then you take the square root of that. Okay, so really what is it? If we set up the proportion, it shows this. X is to 6.9 as 6.9 is to 5. X is to 6, or you can do it this way. X is to 6.9 as 6.9 is to 5. It doesn't matter which way you do it. But looking at it, you can set up that proportion. And as you do that, you see that this is really 6.9 squared equals x times 5. And you take the square root of 5x. That's what we're doing. So as you set this up, you get what x is. But my whole point behind all this is, if you just draw the triangles out, just set up the proportion and solve it. Okay? Because you didn't know what x was. 5 times x, I can't take the square root of 5x. I need to know what x is. So you'd have to set up the proportion to solve it. Got it? Yes? Alright. There's a problem there, but we're not going to do it, so I want to give you your assignment.